In the class 3 we will see how to create sweep and helical sweep, then holes, standard and non-standard holes. We will see these things in Creo. To create sweep we need one curve. We need one curve and a cross section for sweep. So to create a curve, go to sketch, select the sketching plane, sketch, sketch view, draw a spline. This is a spline. You can create. By middle pick we can exit from the spline command. If you pick one more time the scroll button, we can come out from spline. Okay, 400. To modify the dimension, just pick on the text. Okay, switch off the datum planes. If you want to control the node points, you can control by pick and drag. Okay. Now we have created sketch, sweep. Go to sweep, references, select trajectories. We have to select trajectories. We have one trajectory. If we are selecting more than one, n number of curves means, then that is called variable section sweep. We will see variable section sweep later. This is the start point where we have to draw the cross section. If you want to change the start point from here to here, just pick on that, you will get it here. If you pick here, click on the arrow. Otherwise, just hold and right pick, flip chain direction. This also we can do. Okay. Now we have selected the curve. Then next we need to create one section. To create the section, go to edit tool. This one is the edit tool. Pick. This is the start point where we have to draw the sketch. Go to sketch view. We will see one crosshair. On that we have to draw. If you are not able to visually see, just turn. Now I am creating one rectangle. mm, 50 mm, 50 by 25, one rectangle. See, we have created default orientation. Okay. If you want to edit, just pick and right pick, edit. We can edit the dimensions. To modify that, pick on the text. Yes, 55. Okay. Control A is regenerate. Control A. Okay. If you want to roll back, see, go to edit definition. If you want to move to sketcher mode, go to edit definition. If you want to edit the sketch, just pick sketch view. Instead of 25, you can do 30. Do OK. Give. This one is the preview. By picking this, we can see the preview. Once again, if you want to go to edit mode, pick on the triangle. Okay. Give OK. If you want to save, you can save. Now we have created sweep. Variable sweep we will see later. Then helical sweep. Helical sweep used to create spring and thread. We will create both. The spring. This is the spring nomenclature. This is the free length of the spring, diameter of the spring, wire dia or coil dia. This is the pitch of the spring. Okay. And also it's a turn. It may be a right hand turn or left hand turn. The rotation coiled direction. If you want to delete the feature, just pick and delete, give OK. Maybe default. Now we are creating the helical sweep. See, pick and sweep. This is the helical sweep. References. Create a here define. You have to pick the sketching plane, sketch view. We have to draw one center line. This is the axis of the spring, and we have to draw one profile away from the center line. This is the length of the spring. This is the start point where we have to draw the cross section. Create dia. To create the dia, we have to pick center line, this edge, then center line, pick the middle button. Spring dia 100. This one is the length of the spring. 250. Okay, this is the start point where we have to draw the cross section. Then the pitch value. See, this is the pitch value, distance between the coil. Here we have given 25, we will do 20. Okay. Then we have to draw the wire details. Go to edit button. The crosshair we can get. This is the profile. See, it's not visible. Here the profile is there. Sketch view. Here we have to draw the section. See, I am creating one circular spring. Coil having 5 mm. Okay. Do OK. See, we are getting the spring. This is for left and right hand. If you whichever we want, we can change. This is left hand. This is right hand. Sorry. If you want to, this is the constant pitch over the entire length of the spring. This is the length of the spring. Profile defines the length of the spring. See, pitch. If you want to change the pitch, variable pitch, you can add a lot of pitch between the points. Okay. Okay. Then now we have created variable section sweep. Delete. Okay. Now I am creating one thread using the helical sweep. Creating one wall, basement, define, sketching plane, sketch view, center line. I am creating one solid rod having 20 mm dia, 20 mm rod with 150 long. On that we are going to create one small square thread. Go to sweep, helical sweep. Similar same procedure we have to follow. References, define, select the sketching plane, sketch view, take the references. If you want to pick the references, pick this one, pick on the arrow and pick the edge. Hidden line. See, the top also we have to pick the references. Okay. Now we have to draw the center line. This is the axis of the spring or axis of the body. Here we have to cut the thread. Full length or particular length. How much you want we can. For 100 mm we are creating square thread. Okay. We have created profile. Then okay. Pitch 10 mm. Okay. Or okay, we will go with the 8 mm. Then we have to draw the cross section. See, edit, sketch view. See, this is the solid rod, this is the profile. Now we have to create the section. 8 mm we have given pitch, means the cross section must be 4 mm. This and this are equal length with the 4 mm. 4 is too much. Anyway, for practice we will go. 4 mm we have created cross section. The cross section must be half of pitch value for thread, square thread or circular thread. Okay, now we have given. Now this is the solid rod. Why I have created the section inside the profile, means here we have the material, outside we don't have material, so I have created inside the material, and this is for extrude and this for material removal. Just pick on this, go to shaded mode. See, we have created one screw rod, threaded rod. Okay, give OK. Okay, in this way we have to create a thread using the helical sweep. Delete. Okay. Then next one is the hole. How to create holes. For that I am creating one plate. Default. Extrude. Placement. Define. Creating 200 by 100 one rectangular plate with a 10 mm thick plate I have created. In the corner we have to create one hole. For M10 hole we will ordinary hole as well as standard hole we will create hole. This one is the ordinary hole, this one is the standard hole. Ordinary hole means without a thread. This one is the standard hole. Based on the bolt selection we can create. See, here two standards available. ISO, this for metric threads. We used to call M8 bolt, M10 bolts. This is metric one. Then UNC and UNF, unified coarse thread and unified fine thread. Fine thread having more threads than the coarse thread. If you select this, you can see in the UNC half inch, in the half inch, quarter inch, 1 inch, 1 inch having 8 threads. Similarly, now we are going ahead with the metric one. First we will go with the free hole placement, where we have to draw on this surface. We have to drill the hole, just to pick on the surface. Then we have to give two references for locating the hole, from this edge to some distance, this edge to some distance, like that. So we have to pick this offset reference window, then select the surface. To select the another one, press the control button. In Pro E, if you want to select multi surfaces or multi edges, we have to use the control button. 10 mm dia, the offset distance 15 mm, through hole. Now this is the preview. Now we have created 10 dia hole. Okay, this is plain hole we have created, simple hole we have created. If you want to drill profile, we can pick, and if we give the plate is 10 mm, if we give 6 mm, we can see drill profile. We can can't able to get this small one, 5 mm plate. So okay, leave it. Later we will see this. 10 mm. here we can change thread. See, this is the drill profile we are getting. This is the drill profile. See this one. If you want a blind hole, use this. If you want to drill profile, use this one. Okay. And delete this hole. Now we will see how to create the standard hole. Go to hole. This is the standard hole. Pick the metric hole we are creating. M10 hole I am creating. Standard holes have the thread. That's all. M10 into 1.5. Always select the maximum pitch. In the drawing, if they mentioned M10, M8, without pitch means we have to select the maximum pitch. Linear. Now we are seeing the linear hole. We positioned them from this plane and by pressing the control, pick this one. 15 mm. 15 mm. See, we have created hole. We will go with through all. If you go to shape, we can give the thread length. See, if you want to through thread, give this one, or if you want to particular length we need the thread means pick and give the value. We have created only the 5 mm plate, so 3 is not enough, but for practice I am giving. So through thread is better. Give OK. Just a moment, I will increase the plate size. We have given 10 instead of 50 mm we can go. For better visibility, instead of M10 I am changing to M16. To M20 we can go. Then see, we have to change. If we are creating 20 mm holes means thumb rule, in the design thumb rule is from the edge it should be 20 mm. We should not keep less than that. More than 20 we can keep, but less than 20 is not recommended. This is regular practice in design. See, this is a through hole we have created. See, through hole, through thread. This is cosmetic. In the hidden line we can see the thread. Switch off the planes. This is the thread. If you want to add counterbore or countersunk means we can add. See, this is the countersunk. The countersunk head dimensions we can control here. Okay. Similarly, counterbore. This is not okay. Okay, counterbore. This is M20 bolt. It should be 20 or more than 20 only. The entire bolt should go inside. Okay. If you want to include the thread surface and the geometry, we can include. If we don't want the thread, see, if we see, now we have the thread. See, here we have the thread. If we don't want means just remove this. See, now we don't have thread. For FEA, people used to ask the geometry without cosmetics. Otherwise, while converting the geometry into step or parasolid file, the cosmetic features become a surface. So we have to hide that cosmetic, suppress or hide the cosmetic and give to FEA peoples. So this is the hole. Delete. Okay. The hole placement, we have seen the linear hole. See, in this we have the radial and diameter holes are there. Linear means we have to give two references, x and y references we have to give to locate the hole. If we have circular object like flange, we have to go with this option. We will create one more, this option. Okay, default, extrude, placement, define, sketching plane, sketch. mm, okay, with 20 mm thick plate. Now we have to draw hole here. For this we must need axis. So I have created a circular object. If you have any rectangular object, if you want to create a circular PCD hole, we have to create one axis for that. See, this is a hole, placement. See, I am going to drill a hole on this surface. See, as the object is a circular one, so both are same, radial and diameter. I am going with a pitch circle diameter. In the pick on the offset reference window here, just pick the axis. Axis defines the PCD. Here we are giving the pitch circle radius. Then one plane we have to select to provide the angle. See here, 45 degree AB. See, if you select this plane, we are giving the angle from here. If we select, we are going to give in this direction or in this direction anyway. See? Then the hole you can go with the M10 hole. Through all. See, this is the diametrical hole. If you want to create circular pattern, it will be useful. Placement. Here diameter we have used. Instead of diameter, if we changed radius, see, we are giving the pitch circle radius. There is the difference. There is no difference. Only here we are providing radius. In the diameter we are providing the diameter. That's all. All other options are same. Okay. Now we have created the threaded hole. This one is the threaded hole. See, we have the thread. If we want to create a free hole means free hole, not this one. Free hole means for bolts. For if we are using M10 bolt, we needed to create 12 mm hole. See, those things we can create here. By here we added tab. Just pick on the tab. We are removing the tab. Then this icon will come. See, this is the free hole, clearance hole. Just pick the clearance hole. Now we are getting a without a thread but clearance hole. This is, we have used M10, so we can insert M10 bolt on this hole. 3 clearances we can do in the shape: fit, close fit, medium fit, free fit. These 3 is available. We can give free fit. Free fit hole size is 12 mm. For fabrication we are going with 12 mm. If you need any accurate holes, it depends upon the application. If you need tight fit between the bolt and the hole, then go with the close fit, only 10.5. We usually go for fabrication with the free fit. Okay, then this is the free hole. If you change, instead of M10, if you changed to M8 or M6, we are getting the clearance hole for M6. No need to give any dimensions. Based on the bolt size, we are creating the clearance hole for the bolt. Okay. Okay. Now we have completed all the 3. Okay, thank you.